Hello, my name is Alex. I'm going over 5.3, challenge exercise 3. Let S be a vector space that represents all 2x2 matrices where the top left and bottom right entries added to 0. Prove that there are no linearly independent sequences of length 4 in S. So to start off, I took the equation given where the top left and bottom right entries added to 0, and I essentially just solved for the bottom right. And what I found is that the bottom right entry is just the negative of the top left entry, which is shown right here. And using that, I rewrote the matrix and I turned it into a vector, which is right here. And what I found is that all since the bottom right entry can be represented using the top left entry, then we could represent all 2x2 matrices where the top left entry and the bottom right entry add up to 0. We could represent it with just using 3 vectors right here. And I hope that makes sense because it's kind of hard to explain. And so since we could use 3 vectors to represent the vector space S, then the dimension would be 3. And what this means is that you can make any 2x2 matrix whose top left and bottom right entries added to 0 using 3 vectors, and that's why the dimension is 3. And so in theorem 5.3.6 in the book, it states that if you have a vector space, which is this case is S, and if you were to have a if you were to have a subspace of a list of vectors, then if it were to be linearly independent, then it could not have more vectors than the dimension of the vector space. So in this case, the dimension of the vector space is 3. So if you were to have a sequence of vectors greater than 3, such as 4, then it would then the sequence would not be linearly independent. Therefore proving this question.